In this section, we will use a storage event to trigger a Lambda function that responds to the put request. The purpose of this application will build from our previous recipe example. Now we would like to provide pictures of our recipe along with the description, meal and prep time. So what is required now is to load a photo, a picture, along with the recipe, with what we provided before, which is the recipe and the preparation time. To do this, we will use S3. What is S3? It's a simple storage server. As our trigger, we will use the S3 as our trigger, and a Lambda function that appends a recently uploaded image URL to the recipe it is associated with. S3. Amazon S3. AWS offers many storage options ranging from relational database to NoSQL database to blob storage. In this exercise, we are going to explore using S3 blob storage as a trigger for a Lambda function. What is going to happen in this third example of this chapter, chapter 3, is a storage will be used. What is the storage name? It's called S3. What is the S3? It's called blob storage. It's Amazon blob storage, right? What other types Amazon cloud computing supports? It supports relational, similar to the Oracle and SQL, and non-relational, NoSQL databases, and the blob storage, right? Within the S3 service, let's create a bucket. So we'll be creating a bucket. Your current S3 console will look like something like this, 343, just like that. So this is Amazon S3. Amazon S3. The S3 console lets you view all currently active buckets, create a new bucket, and search for buckets. So we are going to create a bucket. As shown in 335, which is the next one here, the author is naming mine. What's the bucket is going to be called? Recipe images MS. The bucket names are universally unique, so you will have to make sure your bucket name has not been used before. All right, but universally, I mean across all AWS regions and accounts. Within S3 settings, while configuring your bucket, you are presented with options such as versioning, logging, and tags. We will leave the default values for now. The only thing we will change in the public permissions, the only thing we will change is the public permissions. We will make the objects in this bucket open to the public so we can access these recipe images from the web. So this is creating a bucket, and all these details are filled: recipe images, region US East, Virginia, and just like that. After our bucket, its perceptive images are configured, we can move on to setting S3 as our trigger and creating our Lambda function using S3 as a trigger. From the Lambda console, create Lambda function called update recipe. This Lambda function will receive events from S3 as an object is uploaded put. It will then update the corresponding object's recipe with an image URL. For simplicity, we will name our image uploads with the key to the corresponding recipe. For example, the recipe for mac and cheese has an ID of 2. To associate an image URL with the recipe, we will upload a file named 2. Why? For simplicity. All right, we match the file name with the ID. Within the Lambda console, configure your trigger to be S3 and select the bucket that you created previously. We just created now. Your trigger will end up looking like 336, just like this. This is the trigger. So we go trigger and just like that. Bucket, event type, prefix, suffix, Lambda enable trigger. Now that an S3 event is set to trigger our Lambda, we can format our function to handle the event the way we would like it to. The first step is understanding the event request that is coming in. To simulate this request, I use the set test even blueprint for the S3 put operation. The following JSON is what it provides, right? We can format our Lambda to handle this request by creating TypeScript model for the S3 put request. We want to specify the object key so we can parse it and grab the associated DynamoDB item in order to place an image URL with the correct recipe. The next section will cover how our Lambda function handles this request, respond to a trigger. As we did with the HTTP request, we will also rely on the AWS SDK to update our DynamoDB table. We want to grab the object key from our incoming event and specify that as our key to the DynamoDB table. Once we have the item we want from our table, we can make changes to it, such as adding an image URL attribute and attaching the public URL to the image of the mail. The following steps summarizes this process. So as a summary of the whole process, we will read these steps. Parse the incoming request to gather the key from the image. Set the image ID to the key ID to search the DynamoDB and find the correct recipe. Your bucket ARN is the beginning of the S3 object image URL. Use this and the name of the image to set the URL in the DynamoDB table. Finally, return the status of the execution. To test the access of our function after zipping it with the shared folder and the node modules, we can upload an image to our S3 bucket. I found a picture of mac and cheese, one of my recipes, and I uploaded it to the bucket. To upload to the bucket, simply go to the bucket location and click upload. The prompt is shown in figure 373. Straightforward, right? Figure 330, not 73, 37, okay? Figure 338 shows the log results from the upload. And here is the log results down there. We can also test the upload by looking directly in the DynamoDB table. As shown in figure 339, the image URL is now added as an attribute with the provided image URL. Just like this. Furthermore, when you open the provided image URL, you are redirected to an image of the recipe, figure 340. just like this. So here's the image. The image is publicly accessible within the S3 URL. As before, there are many ways to improve this Lambda function. Separation of provider logic is strongly encouraged, as well as deploying with the serverless framework. The code of this portion of the exercise can be found on this link. Conclusion of the chapter, and we are done with chapter 3. Let's go through the conclusion, then stop. After that, we will have chapter 4, which will be about Microsoft Azure. But we are not going to cover it in this video. It will be in the next video. Conclusion. In this chapter, we explored 2 serverless applications with the AWS Lambda. You learned how to navigate the console, configure Lambda functions, assign triggers, as well as how to build a couple services to both trigger and respond to Lambda functions. You should now have a good handle on how Lambda functions operate and the power they have within AWS. You should also have a more applicable understanding of serverless functions as a whole and how they can be used. In the next chapter, we will explore the Azure user interface and build serverless functions within Azure. And this will be in the coming video. See you later.